Hi everyone, we'll be starting in just a couple of minutes. Just give me some time. Last time we started the webinar, and then a lot of people complained that they were not able to enter or they were not able to join the meeting. So I will take some time to start the webinar so that all of the interested people can join. For some time, I'm going to pause my video so that I don't feel it awkward that none of you are there on the video. I'm seeing my own face. Guys, I would really appreciate if at least few of you can come on camera. So I'm going to now starting to use my camera. And to be honest, it looks very weird when I'm looking at myself. I would really appreciate for more, I would say engagement, it would look better. Great, thanks Kashish. Gaurav, thank you. Smiling faces at 10 p.m. in India. That's a relief. Shows quite the enthusiasm that you have for learning this or maybe for this webinar. Pawan, thank you. Zoom user, what is your name? You are on mute.
Yeah, sorry. This is Saurabh.
Oh, Saurabh, we just spoke. Yeah, that's great.
Yes. I'll make add it to the name.
Yeah, that's all right. I think we can get started. It's already 10 past 10. We are already 10 minutes over. Right. So, Soumya, thank you. So I think now I have enough faces so that I don't have to just look at myself. And yeah, great. So this is a webinar for Python basics, especially the applications, how it is used in the context of finance. Within finance also, we are not going to cover a lot of applications. We are going to touch upon just the basic ones, right? I will tell you about my experience, like how I have used Python, right? And I would also like to know if you have used Python, right? So that we can learn from each other, like how we are using Python in our work, right? So please answer this poll. So I've been looking at the results of the poll and it seems quite staggered. But all right, 40% people said they have never used it, right? And I'm assuming most of the people here are coming from risk management background, so which is quite surprising. You can yourself see the usage of Python or in general programming going up. So that's very surprising. And then 35% are saying I have written basic scripts, right? And then 20% is I've used it in finance related projects, which is very great. And then just a 5% people say I'm comfortable with libraries like NumPy Pandas. So these results they are very surprising to me, to be honest, right? Because I was expecting people would have at least written basic scripts or have seen some piece of code. So, but anyways, let's get started. So I'll start with a short introduction. I think some of you know. So my name is Prateek. As you might know, that it must be displaying on the screen. And I have I have almost 9 years of experience, right? And I have done several projects in programming, right? So for this particular bio, I would focus my introduction, mostly tailored towards Python, right? uh, on top of my mind, like some of the projects that I can think of is I developed an ETL pipeline in Python, right? It was a very cool project. So ETL, if you don't know, it's extract, transform, and load, right? And I developed that pipeline for the automation of derivatives valuation, right? So are all of you, I'm assuming all of you are aware with the process of Python derivatives valuation, right? Derivatives you must know in general, right? So most of the firms, what they do, they use a fixed template, right, for that. And then what they do is they put all the trade parameters, market parameters, and then use a third party library such as numerics or any other murex, right, to price the trades. This is a standard process, right? You must be doing hedge accounting, MTM, mark to market, right? So, but the fundamental first principle is to price the trades, right? And this is the process. Earlier, what we used to do, what we used to do is, even in my previous firm and my current firm, and this is a general process, right? Is take these parameters, convert them into Excel fields, and then put it there, right? Now, this is a typical task that can be automated. Why I am starting with this introduction? Because a lot of people, they just don't know that why firms are demanding Python so much, right? So these are the kind of, this is just one project which I am telling you, right? Other typical projects that are almost always done in Python or let's say SAS are model validation. So all the tests. Uh, so can you put yourself? Yeah. So a lot of firms, like the model validation test that you do, right? Pricing that you do, that is done in Python, right? In fact, recently I saw, so most of the times credit risk modeling is done in SAS. So anyone here from credit risk background? Can someone in the chat mention if you are coming from credit risk background? Right. Fazan said yes, right? So people who are coming from credit risk background, they must be knowing that, mostly they use SAS and R, right? Because a lot of advanced libraries are not required in credit risk, right? For example, you don't need to simulate a lot of paths, right? Asset paths or something, or Monte Carlo simulation. That is not typically done in credit risk. These are the things which are done in market risk and counterparty credit risk, right? But recently, what I realized is that people have begun to transform their SAS codes to Python codes, right? The reason being, Python is open source, right? So it is free. But SAS, it is an enterprise solution, right? So you need to pay for that. That is one reason. And second is, Python adoption has increased over years, like, almost exponentially. The support of open source combined with the fact that it is free, and right now, like, even the regulatory approvals, like the results that it generates, they are approved. So generally, initially there was some, I would say, uh, the regulatory bodies, like, they were a bit hesitant because SAS is more like, enterprise focused. So they were like, okay, we will take this more seriously, like, because Python is open source, so there is no one to sort of regulate that. But now they are open to accepting Python solutions, right? So a lot of model validation exercises that we do, they in marketers, we were already doing that, but in credit risk also, like there were a lot of projects which were simply transforming the existing code base from SAS to Python, right? Or moving from C++ to Python, right? So this is just a background of the type of work that is done in Python, right? And see, this is Python is all about programming, practical use, how to use it practically. So I've not prepared any boring slides to just sort of like, give you any PPT or anything. We are going to keep it very interactive, very informal. So it's more of a Q&A and less of a webinar, to be frank, right? So this was the basic introduction. Now I will just share my screen and I will first check what did I sort of like, promise to you for the purpose of this webinar. So just a second. Share. Share. Someone wants to admit right now. So we can make this. Yeah. So understand essential Python skills. Wow, that's going to be a challenge for me to make you understand basics of Python within 1 hour, less than an hour. Apply real world scenarios, right? Wow, that's going to be another challenge. I've already given you a flavor of what's done, but to give you a hands-on projects experience, I'll try that. Stay ahead of industry trends. Gain insights on how Python is transforming risk management and financial analysis. I think the example that I gave you about two examples, like automation of derivative solution, because this is done at a very large scale, like in all the big fours and in general in all the banks, there is a separate team for derivative solution, right? So automating this is a very standard example and like a very good example. In financial analysis, see, I'm not going to speak about the general, like, importing data from using Yahoo Finance and then doing some analysis, like, those are very basic courses. I would rather give more practical, relevant examples like options pricing war. Those are something which are asked in interviews, and those are the projects which are being done in the industry, right? Join a vibrant community, right? So if you are not familiar with our programming community, I would suggest you to please join that. Right now, it's not very vibrant, to be honest, but because I was working full time, but it's soon going to be very vibrant, right? So, all right. So I think let's start with understanding essential Python skills. But before I do that, I've spoken for 10 minutes almost in a stretch. Uh, I'm going to take a pause and like, let you ask any questions. Like if you have any questions, you can shoot towards me. Anyone? Are you feeling sleepy, a bit sleepy? Like I hope I'm not taking your sleeping, like, I'm not disturbing your sleeping routine because it's very late in India, right? So I think for other time zones, it would be a bit manageable, although it's a weekend, but in India, it's very late. So please pardon me, right? All right. So understand essential Python skills. What are the essential Python skills? So see, the idea is a lot of people when they say that, as we saw in the polls result, like they have almost never done Python, there is an inherent fear that programming or Python, like, in general, would have a lot of concepts to learn, right? And that inherent fear, right, is an inertia for them. They think that it is something a completely different subject, or like, they will have to spend hundreds of hours in learning it, right, to in order to become eligible for a lot of jobs that put Python as a prerequisite, right? That is not the fact. Here what I call is, like, we can easily follow 80-20 principle. So have you heard of this Pareto's principle, 80-20,
Yes.
right? So what does it say?
It says 20% of the effort, um, which are more impactful, we should prioritize that, and the rest 80% will follow.
Right, exactly. So the 20%, if you focus on those basics, you do that right using first principles. So 80% of your task would be accomplished using that, right? Here we apply, if we apply the same principle, so how it translates it is uh 20% is like, essentially identifying those fundamental topics, right, which you must master, right? So regardless of what people are saying, that, now chat GPT is there, a lot of AI tools like Cursor or this GitHub Copilot are there, so we will not be needing programming, or like we don't have to learn it. It's not like that. The same example or the same analogy that, when calculators were invented, it was not like we stopped learning how to do basic algebra, basic manipulation, basic maths, right? So it's the same thing. These 20% are non-negotiable. You have to master them, right? It's not just about Python, it's about any other programming language as well, right? So what are those 20%? There are not many topics, there are just 6-7 topics. I can list it down, just, for example, these are how are basic, how does basic data is like, stored or like, declared there, right? So what are basic data types and data structures, and different between these two? These are two different things in Python. Then what are variables? How variables work in Python, right? Then a basics about commenting, right? So learning how to comment is very easy because you just need to learn the syntax, right? For example, how to write single line comments or multiple line comments, but to use them smartly is up to you, right? Because it's about annotation or documentation of your code, right? It is very useful to make the code readable, right? Because for example, most of the times more than one people would be working on the same code. Or sometimes what happens, like let's say a person is working on a code and then that person quits the job, right? So then you have to do the knowledge transfer, right? So reading, and every person has their own coding style, like you must have heard it, right? Like each person, for example, if your handwriting is different, not to the same extent, but each person has a different way of writing codes, right? So you must need to write the codes and annotate them, and by annotating I mean comment them, to make a person understand like what is the purpose of this particular piece of block, right? Then your third concept would be conditional statements, right? Conditional, as the word condition says, it is to define some like what action would be done based on some condition, right? So its condition is something like if. So first I will tell you the keywords. These are if, elif, and else. There are only three keywords in conditional statements. You can use these to write if there is a conditional flow which is happening. And I will give you a very relevant finance example. How many people have heard of options? Options, options trading is done. Options in derivatives markets, right? Have you ever heard of options? Like how the payoff is defined? Just say yes in the chat box if you have heard of options. Anyone? Only 2-3 people. That is very all right. So more responses, which is great. Yeah. So as I was saying, that options have a payoff. So it will only pay at the maturity if your stock price, like the underlying, right, of the option, it is greater than a certain amount, which is called the strike price. So if it strikes that off, so then it will give you a payoff. What is that payoff? The difference between the stock price and the strike price, right? You can see like it is a conditional dependence. There is a dependence, right, on the underlying stock price, like how it will move. It will be dependent on market volatility, a lot of factors, right? So based on that, how stock price moves, then your payoff would be defined. It could either be zero or it could either be the difference between the stock price and the strike price. You can see a condition developing. So we can write a conditional statement which says if, right, and you need to declare your variables first, like this is my st to, let's say, denote your if you remember, like mathematics, we used to denote let x is equal to this, let y is equal to this, right? So there are a lot of memes on that also, like we never used to go to use them, like but the idea being here also you also declare variables like this, right? And you have declared that st and k. So now you write if st is greater than k, then payoff is equal to st minus k, else zero. Else payoff is equal to zero. So this is one example of conditional statement. So conditional statement is one more foundational tool. So we have by now seen two or three. This is the third one: data types and data structures, variables and commenting, and then conditional statements. What is the fourth one? Fourth one is your functions, right? Now see, let's say you are calculating the payoff of just one option. So one conditional statement is sufficient, right? But what if I ask you to do it for multiple, like, I say that, hey, for example, Kashish, you have to value multiple options each day, right? So then you are not going to write this again and again and again. What you would say, oh, this is a repeated task, I'm going to write a routine or a function for that, right? Because if I know the input, I can get the output. Right? In this case, what is the input? What is the input in this case, and what is the output?
We are inputting the options, the underlying price and something, and in return we'll be getting the option price, the call option, the amount that need to be.
Right. Technically a slightly modified version. So we are putting in this particular case strike price and the stock price at maturity. There are two input variables, right? And output is the payoff, right? So you convert the conditional statement into a function. So you define a function calling, let's say, payoff def payoff, which takes two inputs, and then write the return your whatever you have calculated using your conditional state. So we have covered 4 topics, 2 more, right? Fifth one is loops, right? So I ask you to do this for multiple times again and again and again, right? So you can write a loop, which, let's say, I provide you this as I create a Excel file, let's say, or CSV file, in which one column is ST and one column is K. All right. So it has stock. Are you able to visualize what I'm saying? Simple enough, or do I need to write it on Google Sheet?
Well, we are able to visualize. I mean, I'm not sure about the people, those who are not having a good background in the option pricing or something. But yes, since I do understand that, I can visualize.
Okay, so I think then you are not the right person to ask this question
Yes,
to.
yes.
People with having minimal background or no background, are you able to visualize and follow along?
Yeah, to some extent, not.
Okay, to some extent is better now for now, right? Right. So let's say you have two columns in an Excel file. One column stores your stock price at maturity, and second column stores your strike price. And these two columns are sufficient to calculate your output, which we are going to store in a third column called payoff. Right? So we are going to read from this file, and output we will calculate, and then we are going to write in this file. This is an automation task that we are supposed to do. Right? So what we're going to do, we are going to use a loop, read the value from first row, like what is the strike price, what is the uh, stock price, and then we are going to use the function that we had just discussed how we are going to write it. We are going to call that function within the loop. We are going to calculate the output and write that output in the Excel file. And how to do that, like, okay, there is a syntax for it, like open file, open to open file, and to write in the file. Just ignore that for the moment. Just try to understand the process of loop and why we use loops, right? Because this is a repetition task that we have to do for multiple rows, right? So we have to feed the data in this manner, row by row. This is one example. A similar example could be when you, like, you are using any time series data, where you have to, for example, use the entries of daily, like, every date, like what was the PNL value, and then you have to calculate VAR or something. So the formula could be different, but the process essentially remains the same. Right? So there you can use the loops. All right. The next, so I think we have covered the fundamental blocks. Like there is nothing else, right? Still, I would say something which I still consider as part of fundamental block is external modules, although there are multiple, right? Because Python is open source, and, like, it has great support for almost all the applications. Like, for finance, you have libraries. For quant finance, you have quantlib, for example, a dedicated library. For image processing, for scientific computations, you have scipy. But most importantly, I think you must know these are two, NumPy and Pandas, right? and matplotlib for visualization, right? You can also use plotly, but I think matplotlib is good enough, fair enough, right? So must know are these two, numpy and pandas are non-negotiable. These you must know. Why? Because these are used when you are, so I gave you the example, like the data would be there in an Excel file. So let's understand the difference between NumPy and pandas. NumPy is used when all the columns have only numerical data, right? It will not have any other data like strings, characters, list, or any other thing. All right. So it is used in that case. And then pandas is something which is, you could say, a more modified version of NumPy, because first of all, what is the full form of pandas? Can anyone tell me? Anyone? You must have, okay. Have you heard of pandas? This library? No. Oh, no one? No one has heard of it? Yes. Okay. One at least. Two, three. At least five people I'm expecting must have heard of pandas. So I need two more. Faster than NumPy? Not necessarily. In fact, I don't think so. That's true. Yes. Okay. Five. Yes. Pandas is for panel data, right? Panel is something you can understand, like it's a matrix, right? It's for panel data, and it can have like any type of data. It need not be limited to your, for example, only numbers, right? I'll tell you like why one is used over others. So we have seen in a lot of cases that we do SQL queries to get the data of users, right? It has city name and postal code and like maybe the gender, right? And there, for example, if you are building a credit scorecard model, so they will have all of their information, like like this, and then salary, age, all of that, right? Now it has strings as well, and it has numbers as well, right? So in this case, if you are doing operations, so it will not be faster than NumPy, right? But because of the structure of the data itself, you cannot use NumPy because NumPy is limited to numbers, right? So then you have to use pandas, right? And then let's ask another question, that if pandas can handle both numbers, right, and other mixed data, so why to use NumPy itself, right? That's because NumPy provide NumPy provide functionality of something called vectorization. What is vectorization? So this is something like it's part of a bit advanced topic, or at least intermediate topic. Not, it is not basic, right? Not advanced also. Let's call it intermediate. Vectorization is nothing but you are considering the entire column as, let's say, one variable and then doing operations on it. You can do that instead of running a loop, right? So for example, when I was teaching you or telling you, then it was not a proper teaching. I would not call that teaching. Uh, so when I was telling you about loops, I was giving the example of stock price at maturity and strike price for various dates, right? And then I was telling you can use loops to do that, right? But imagine that this is just a numerical data, right? Just numbers. So you can use NumPy and just write one line of code to do that. So you can just eliminate the complete process of using loops, right? So that is why NumPy is much faster for numerical operations. The only limitation is that the data it is looking at, it needs to be in numbers, right? So that's why, like, when you're looking at a piece of code, you would mostly be looking at that it has both NumPy and pandas imported, where non-numerical data is handled by pandas and numerical data is taken care of by NumPy. All right. Up until this point, like, are you feeling a little bit better than what you knew earlier, like somewhat, or like still feeling lost, a bit better, a bit confident, like it's not that difficult. Because see, I didn't even use any slide, I didn't even open my terminal, and I just told you like a story, right? So, and that's it, like that's those 20% what we were discussing, that's it, this is it. Beyond that, if there is anything, you can just Google it, it's okay to Google it, but this is something that you must know. Until unless you are into a job, for example, which requires some types of jobs may require a lot of simulations, right? So then you must be familiar with some sci-fi like operations, like how to interpolate or these kind of things. Or if you frequently use plotting, so then you must know some functions of matplotlib. But apart from it, if you are looking for a entry level role, or if you want to just get started and know about Python, so these are the 6 topics that you need to master, right? And just imagine, like, we started at 10:10. It barely took us how many 30 minutes to get ourselves familiarized with these topics, right? Within 1 month, if you practice good enough, you would be able to master these concepts, right? And after that, until unless like there is something advanced topic, for example, oops concepts, there is something called object oriented programming, right? So what is object oriented programming, we are not going to cover here because that's a bit beyond. And to be honest, the reason I'm not covering that is uh, it is not used in a lot of the roles. It is not used, like credit risk, you would never see oops concept being used. In market risk, it is used for complex models, especially in model development, right? You're building curves and you are using quantlib, which has like these yield curve objects, right? But basically, what it is that you can write a class which has its own data types, custom data types. You can define it there, and within that, you can also define a function as well. Like, for example, consider a game. That is a more good example. So, have you heard of GTA? Have you heard of this GTA meme? Like GTA 6 is not coming, but this has come. Like whenever anything new happens, you see the meme that this has happened before GTA 6. GTA is Grand Theft Auto, a game. So have you heard of this? Okay, maybe I am in a but any game would have, like, let's say cars, right? Cars or any metrics or anything. Right? So cars are there, and cars, if you have to create an object, right, of class car. Now each car can be customized, right? For example, each car can have a different color, right? Each car can have a give me examples of parameters that a car can have. Mileage, right? What else? Torque, right? What else? Design would be very a vague term in this case, until unless you are giving specific attributes to that. Make and model, right? So for example, yeah, electric or non-electric, this is, yeah, maybe like engine type or something we can call a variable, and then it could be electric or non-electric. So this is a classic example of an object. You can create an object car, and then you can within that car define these variables, that to construct a proper car, uh, right, you need to give these parameters some value, right? So for example, if you are creating a Tesla car, so a particular model of Tesla, so then you will give it color, and then it would be electric, right? And then you would define all of the parameters that we discussed. So that is objects. I would say this is not part of 20%. Why? Although it is one of the fundamental concepts, but in 80% of the roles which are open now, for example, credit risk, liquidity risk, right, and a lot of market risk roles also. For example, for calculating VAR, you don't require object-oriented programming, right? Until unless you are building the entire model and then doing it, right? VAR assumes that pricing this P&L vectors and returns, these are inputs to the VAR model, right? So for 80% of the roles, the first 6 topics that we discussed, right? I'm going to revise once more. What are those? Can someone list any, in any order? Can you write about those 6 topics in any order? Just you can write 2, 3, whatever, you don't even have to write all the data structures, data types, conditional statements. Amazing. Captured everything. Loops. Oops, you missed the loops. Right. This covers everything. Right. This is, I think, comments. Yeah, comments. So I have a comment on comments that you have not included that. But yeah, that's everything. Right. So with this, you can get started and build a lot of cool models, right? For example, let's take a classic example of bonds valuation, right? So, but here again, I would assume, are you aware of how a basic bond works? Not a zero coupon bond, but a bond which provides continuous stream of cash flows, uh, which is dependent on the coupon, and then a face value. Where is Shubham? Shubham, can I see your face? You seem to be answering a lot of answers, a lot of questions. Can you come on, turn on your video? I can't see Shubham. Okay. Anyways, great. Uh,
Yeah. Can you see me
yes,
now?
yes, yes,
Yeah.
yes. I can see you. Great, guys. So electricity here has gone. I'm connected with my hotspot, and I might look a bit spooky. So please bear with me. Okay. So what were we discussing? Yeah, bonds, right? So not James Bond, but corporate bonds, right? Or the bonds that we trade, right? So how many of you are familiar with bonds? I'm expecting Saurabh is familiar, right? Yes, yes. Okay, these are multiple. Yes, that's great. Okay, so a bond is what? A stream of cash flows, coupon payments, right? And at the end, a face value. So if I were to calculate the price, right, present value of a bond, what would I do? I would run a loop, right? I would run a loop on all the cash flows, right? Discounted values, and sum them up and add the discounted value of face value. Now, this is a classic example and very easy example where you can use loops to price a bond, right? Can you just sort of draw an analogy? Like, can you visualize? I know, when you would do it on the terminal, so then you would get more familiarity, but are you able to visualize, right? Great. So I have covered those basics, right? And I think within 1 hour, I cannot cover more than this. So understand essential Python skills. This we have done. Apply real world scenarios. We have taken 2 examples, options and bonds. Like these are most common ones, right? If you can value bonds, you can also value swaps. Do you agree? Do you agree with the fact that if you can value bonds, you can value swaps? Hmm? Right? Because swap is nothing but the difference of both the legs, like what you have priced, right? So now you have learned options, bonds, and swaps. But effectively, to be honest, options we didn't learn the pricing, we learned the payoff part, right? Right. So, but options pricing, Black-Scholes model, if you want to do, so that's just a formula. So that's nothing, right? So I mean, it's a simple application. You have a Black-Scholes formula, you apply that, and you can calculate the options price. Right. There also you can use conditional statement that if option type, let's call a variable option type. If this is European, So then use this formula, else if option type is equal to, don't use else, use elif. Elif option type is equal to put, use this formula, else the last one would always be else, print invalid option type, right? A default. Great. So what I promised to deliver, I have delivered. I have hopefully delivered these two. Stay ahead of industry trends, right? And this though I told you now, what they how, like how Python is used, like it is used for automation, it is used in model validation, model development. In audit, it is not used. Audit is all about documentation. It is used for migration of legacy code base to Python code base, which is happening in a lot of firms at this point of time, right? Where else it is used? Can someone give me more examples? I'm running out of examples. Where is Python used? Why do firms ask like for Python? I remember like when we were doing liquidity stress testing, like so that was something like most of the firms earlier they used to develop this stress testing, and a particular example being liquidity stress testing. Because what happens, like deposits reprice whenever interest rates change. So based on that, your non-maturity deposits, like they need to be repriced, and you have to calculate like all the numbers, right? So there earlier, what firms used to do is to use Excel, but then it is very difficult to sort of like like it is prone to operational errors, right? And it has dependency on people, right? Python code, if generated successfully, tested successfully, it reduces dependency on people for running faster simulations, right? That's true. Because if you do it in Excel, it would be very slow. Compared to Excel, it is faster, but again, to iterate, not to iterate, so sorry, to add on top of this, Python is slower than Java and C++, right? But the type of work that we do, right? So for example, we calculate var for 1 day, right? We don't calculate it for 1 minute, right? Or for 1 second, right? Java and C++ is used for high frequency trading where low latency and high computing, sorry, no, not computing power, where speed is high speed is required, right? And low latency, right? Python is used where speed does not matter that much, right? When we say does not matter, it doesn't mean like it should be as slow as Excel. It is fast enough to do your what you want it to do, the task that you want to accomplish. At the same time, it is readable enough. Python code is very readable, right? If you want to declare a variable, you don't need to do any additional task. You just write the name and then assign the value to it, right? So yeah, this is about it. And yeah, I think that's it. We are done. I wanted to actually run some codes also, to be honest. I had some codes, but I think I would save it for Python sessions. I can see if I can run I can give you a glimpse of the code at least, because I think it would take a lot of time, and if people have started to leave the meeting, so maybe they must be late for dinner or sleep or some family obligations. But let's say, okay, so for var we have parametric method, right? We have variance covariance method, right? And we have a historical method. These are the three most commonly used, these are the three common methods for calculating var, but the most popular and the most commonly used method is historical method. So as you can see this piece of code, I would take a closer look at historical var, right? So see, I cannot teach you how to do it in this session, to be honest, in case you have zero familiarity with it. But even if you can see, so you'd be able to realize from the code base that it does not require any sophisticated calculations. Like you are here defining the time frame of your data, right? Here you are defining your portfolio, right? And then you're calculating returns. Then you are assigning weights to your different portfolio stocks, right? Uh, then based on those, then you are calculating weighted returns, right? You are dropping the NEs, like, basically you are doing some data filtering. And then based on the confidence interval, you can simply calculating the percentile. It's that simple, right? So if anyone asks you how to calculate historical var in Python, you should not be saying I don't know. You said it's this simple. This code has, like, literally no complex object oriented programming or complex libraries or anything. It's very, very simple. You can see how it's plotted, right? Similarly, this particular notebook has, like, other methods as well, like parametric var and variance covariance method, right? But I just wanted to give you a glimpse like how super easy it is to calculate var using Python. This script, for example, calculates your options pricing. Let it open. I won't be able to run the codes because, like, it would take a lot of time. But this is Black-Scholes model, as you might know, right? And here we are using SciPy, right? Then we are simply defining D1 and D2, what goes into the formula, and then we are calculating the call price, right? If we want to write the same logic, if you want to convert the same logic into a function, right? So there are 5 parameters to it that we have put. We are assuming no dividends, right? And we have converted it into a function. Then there is a binomial model, which is the other model that we use to calculate options price. So here, like, all the variables like probability of an up move, down move, and the time step size, those are defined. And based on that, like, we have constructed a tree and calculated the price. This is, by the way, I mean, if you can understand this piece of code, you would feel modeling interest rate trees, like, very easy, because a lot of interest rate modeling has to do with constructing trees. Right? What else do we have there? Yeah, this is just, binomial model continuation. So see, if you have done FRM part 1, or at least have studied part 1, book 4, which is evaluation and risk models, 14th chapter, which is about binomial trees model, right? So then you can easily see like how this equation is coming up. So this is like, we are doing back propagate to filler tree and then calculating the call price at the 0 means the first position. So this is the price, right? And then we are converting the same piece of code to binomial. Yeah, so this is something, there's a reason I'm doing it in this manner. So see, when I was working, I learned something that, there's something called unit testing, right? What do you mean by unit testing? That you run the code for, let's say, I is equal to 1 or I is equal to 0 cases, right? So that's why whenever I code, what I do is I break down into smaller components, run them, test them, and then I see, okay, in this entire piece of code, what are the inputs, what is the output, and then eventually everything is going to be in a function, right? Which it can later on be converted into a, let's say, class as well. For example, if you want to construct a class called options, which give you its price as well, which give you it Greeks as well, right? So you can write the formulas for Greeks and then put it inside a class, right? In the same manner. So this is nothing but just a function which is this is a modularized version of the above code. This is implied vol calculation, right? So the concept of implied vol comes from the fact that, your pricing determines the volatility. So you're essentially putting the, in the Black-Scholes formula, you are putting the option prices which are being traded in the market, and then calculating the volatility which is implied by the equation of Black-Scholes. So here we are defining our objective function that we need to minimize, right? And yeah, this is a simple formula, right? We are using this fsol, right, which takes the objective function and the arguments. These are the arguments. I'm not going into the details, right? But the idea here is like from SciPy library, as I told you earlier, like, if there are any optimization, interpolation functions like, this, which require a slight level of scientific operation. So there we import SciPy library, right? So I have given you a glimpse of this as well. And then these are basic operations I've already told you, right? Uh, in detail, like, we would cover all these sessions in this Python bootcamp that we are going to start from 31st, right? So these are the same topics that we are going to cover. Do these in detail. We assume that you know nothing about Python. I'm going to take it Saturday and Sunday, 12 to 2, right? And then the sessions, for example, if you're not able to attend a particular session, the recording would be available to you, right? So yeah, that's pretty much it. Everyone, if you have questions, I want to stop sharing my screen. So did you like this? Did you find it helpful? How many people are left eventually? So people, did you like it or not? I think no one liked it. Okay, any questions? I think people have just put themselves on mute and have gone to, like, all right, so any questions?
So specifically in this boot camp, are we going to, as you walked us through the Black-Scholes-Merton model, so we'll be covering the Black-Scholes-Merton model and other, like the financial analysis that we mentioned at the in the agenda. Are we going to cover all those in depth?
Yes, we are going to cover everything. So what I just said, like, we would be covering that detail. So that's why, like, I didn't open those files because it would not be possible to go through all the codes right now and run this. And the idea is, like, as you could see from the results of the poll, like 75% of the people are on very foundational
Yes,
level,
yes.
right? So the idea is that at the end of this 4 weeks course, you would be able to confidently understand and even, in fact, like, write this in your CV if you want to. No one is going to question you, because if someone asks, you can tell them this is how it's done,
Okay.
right?
And are we also going to have any capstone project after the end of this course?
So see, the capstone project would not be there because the idea is like, for example, options pricing is covered by both methods. VAR modeling is covered by both methods, right? Bonds pricing is covered. You can calculate swap pricing by yourself, right? If you want, I can share some, like, notebooks if you're interested, right? But the idea is like there are 6 fundamental topics, and then these 2 sessions, additional sessions, these themselves serve as like sort of capstone projects.
Okay.
But yeah,
Yeah.
that's an interesting idea. Like, we can add that in the bootcamp so that people are motivated to do something on their own and present it.
Okay. Makes sense.
Right. I would just give me 1 second, huh? I have one question, and you can answer it in the poll here. Not poll, sorry, like just in the chat. Like, in general, on average, if you're interested in learning Python, so how much time can you commit per week? Hmm, Julia for building trading strategies versus Python. So see, to be honest, I don't do trading at all. And Julia, I have never, matlab, I have heard of it, but I am not going to give any opinion for a language that I have never used. I have used C in my college. I have used C++ to a bit of extent, like on my own. Uh, but I have never used Julia. I have used R. I have used SAS, and as I mean, I like web development, so I know some JavaScript, HTML, these kind of language, but I don't know. If it is more towards like centered towards compiler, so it would be fast. So I think it would be better. But I think a lot of people whom I have spoken with who use algo trading strategies like HFT, and by trading strategies I am assuming like you are focused, you are considering speed as the major factor, so they use C++ or Java. Okay, 9 hours per week, I think that's good enough, like because I don't even expect that much amount of time. I think even if someone gives 5 hours per week, so 20 hours I think are sufficient to cover the basics. That's it. Then after that, it's all about practice. If you're not going to practice, you will get rusty. So it's always about finding interesting topics. For example, I've written LinkedIn posts on for types of topics that you can build, uh, that you can use Python to sort of translate those topics into practical applications, right? So you can pick that post and then do it yourself. Like for example, part 2 has a lot of interesting applications, calculation of CVA, PFE, EPE, right? So those kind of things. Or in part 1, you have valuation of swaps, bonds, options that we discuss, expected shortfall, a lot of things. Practicing, like what do we practice? Python codes general or this? See, if you take up topics from Python, sorry, part 1, they are in general aligned towards general finance, right? I mean, both risk management, they are used in risk management also, and they are used in general as well, right? So as I told you, like options, bonds pricing, VAR, expected shortfall, binomial trade, Greeks, right? So these are in general finance topics. Doesn't matter if you are in risk management, if you are in trading, if you are in portfolio management, right? If you are in a quant role, front office role, you should know those, right? And don't go for general Python codes. For example, I've seen people who take like 300 hours of Python. I don't know what do they, how do they brand it or something, but like mega course or something like that, where they will teach you, okay, very generic, like a lot of things, everything they will include, right? So don't go for that. Don't cover those 80% topics which would only serve your 20% of that job, right? Cover those 20% topics which are focused towards finance, and completes your 80% of the task that you will be doing in the future, that you aim to do. Got it. All right. More questions, guys? You can ask them either in chat or either by unmuting yourself.
Hi, Prateek. I do have a question. From what I understand, market risk and liquidity risk, that is your FRM part 2, they have they don't have that much of project or that much of coding required in comparison to credit risk, if I'm not wrong, right? And I mean, if my understanding is correct. And if that's the case, what all topic would you suggest for practice or coding for market risk and liquidity risk topics?
Liquidity risk, to some extent, I would agree with you that they don't have a lot of, you know, individual topics to on which you can build some projects. I mean, there is, for example, you can build a liquidity stress testing project, but that would be sort of a mega project because it requires inputs from several types. Like anyone who has worked on liquidity stress testing, I'm not sure if you're here, but it requires inputs from a lot of tabs in Excel. So basically, a lot of input data is required. So you will not find that in FRM. But I don't know why you would think that market risk does not require Python that much. It's opposite. Market risk requires more Python than credit risk, because first, it is faster, right? So you would not use Excel, like, sometimes, I mean, you need to have that, right? And let's say if you are using a library such as quantlab, right, which is required for, let's say you're building an interest rate model, how would you do that, right? So for market risk, I think most of the chapters which are there, almost every chapter would require Python. If you have to build interest rate models, then, right, you will have to construct
Right,
trees
right.
and everything, right? So,
Right.
and then if you have to generate, let's say, backtesting reports, so automation of backtesting is something very commonly, which is commonly done in major banks, right?
No, I'm really sorry to. But I was talking not in terms of Python as language, but in terms of coding or projects that, personal projects that we can do it on our own free time. Isn't credit risk part, or, doesn't credit risk have majority or more of projects that one can do in comparison to market risk?
No, I don't agree with that. So, for
Oh,
example,
okay.
yeah, because in market risk, let's say, within interest rate modeling itself, you can say there are multiple models like Halvite one factor or two factor models, Check interest rate models, Fox and Russell Rose models. Then you can construct volatility models, right? So
Right,
in
right.
part two, it is not there, but you can construct, let's say, volatility smiles, skews, right?
Yep,
Using
yep.
Python. So those kind of projects you can do, right?
Right.
In
Right.
credit risk, right, a lot of what you can do is under counterparty credit risk. What is generally done in credit risk, I think, is not covered in detail in the FRM part 2 syllabus. Like, a lot of work is being done on scorecard models and the current expected credit loss and those kind of work where programming is used.
Correct. But then you do have your PFE and EVAs or CVA, XVA as well in credit topics, right?
Yeah,
I think those are covered already.
that's what I said. Like, those are in credit counter, but those are covered in credit risk book, but those are part of counterparty
Counterpart.
credit risk.
Correct. Okay. Yeah.
And then, right, and one more thing is, like, in FRM part 2 curriculum covers counterparty credit risk under credit risk. But if you would look at the market, like when people are hiring, right? So when firms are hiring, so they would prefer candidates with whose background is more aligned towards market risk for
Right.
counterparty credit risk roles, because
Correct.
it requires simulation, Monte Carlo simulation, understanding of interest rate models, derivative markets, those kind of things. Right. Right. For example, you have a separate CVA desk as you have it for different asset classes like FX desk or commodities desk or interest rate desk, like that.
Okay. Okay.
Right.
Yeah. Cool. Thank you. Thank you.
More questions, guys? We good? All right. So thank you everyone for joining. I hope it was helpful. And if you're interested in the bootcamp, just drop me a message after this webinar, right? And we are starting from 31st of this month, right? So there is barely 1 week left. So you're welcome, Prakash. Right. All right. So see you there in the bootcamp if you're joining, right? Otherwise, let's keep the channels open. You know how to contact me, right? All right. Thank you, everyone. Take care. Good night. Bye.